Hey, ChatGPT, write me a good phrase to welcome my guests for today's AI webinar. Make sure it's funny and witty and makes me sound like an AI guru. Welcome, everyone. Today, we are going to talk about how we built an AI lab because clearly it wasn't enough to just use AI. We had to build a thing that powers it. And if you're wondering why, well, that's what today's session is all about. Expect a little bit of jargon, a sprinkle of tech magic, and hopefully by the end, no one's GPU will have exploded. At least not in this session. Well, that was one of the ways I use ChatGPT, and I am sure all of you use different tools for different reasons, from coding to creating content and to doing a lot of interesting things as well. Well, I am Atul Priya Sharma, your host for today's webinar. I am a senior developer advocate at InfraCloud Technologies. I'm also a CNCF ambassador. While I focus on building POCs on everything related to DevOps Cloud Native, more recently I have been playing around with a lot of LLMs and Gen AI tools. And today's webinar is something where I am going to learn a lot of things along with you. For those of you who don't know, this is the second edition of our webinar. We call it AI Explore. And in this series of webinars, we would be exploring everything related to AI, from AI platforms and AI infrastructure to AI frameworks and AI applications. Our first episode today is going to be about this. I'm sure a lot of you would have seen this image on either Twitter or LinkedIn. And this is our AI lab that we have set up at InfraCloud. Well, just like you are seeing it for the first time, I am also seeing this image for the first time. I have not seen this set up physically, and I'm hoping that I get access to have a look at it and play with it sometime in the future. So, like I said, our first episode today is going to be around how we built our AI lab, and it is going to be a practical walkthrough. And like you all know, probably that we have been doing webinars previously. So, the previous edition was focused on platform engineering, and I would say that it was a good success. So, if you want to know more about all the videos that we did, all the webinars related to platform engineering and everything else, do scan this QR code that will take you to our YouTube channel where you can watch all these videos on demand. And don't worry, I am not here to be talking for the entire 40 minutes. I have some familiar faces here who would be giving me more idea and telling us more about AI and our AI lab. So let me bring upon my guests for today. We have Vishal and we have Sanket. Hey Vishal, hey Sanket, thank you so much for joining in.
Atul.
Good. Hey, good to see you both. Thank you so much for sparing time from your busy schedules and telling us about why we built an AI lab. I mean, even I couldn't get hold of both of you during our office hours, so I had to pull you out of office hours to discuss this today. So before we get started, a quick round of introductions from both of you. Tell us where are you joining from, what do you do at work, and what are your interests outside of work. Vishal, would you like to go first?
Cool. Thanks, Atul. Thanks for arranging this. Excited to be talking about stuff. Vishal, founder and CTO InfraCloud. Been doing and tinkering with infrastructure technologies. And specifically last year, a lot of stuff a level below hardware, operating system, and whatnot. Some of that we'll hopefully cover today. Beyond work, I like to be in the nature, mountains, or small hikes around, and either reading books or, good movies, basically.
Hey everyone. So this is Sanket. I'm principal engineer at InfraCloud. Uh, my interest areas are like AI, cloud native, and distributed systems. I've been dabbling with AI in past 1 year, and I've been focusing on building out the lab that we are sharing today. And beyond work, my interests are mostly reading and playing badminton, cricket, etc.
Interesting. So we have a nature lover who likes to read books, and we have a badminton player and a cricketer who also like to set up AI labs. So before we move further into this webinar today, a few housekeeping stuff. We would be taking questions. So if you have any questions during the webinar at any point, please put them in the comment section from wherever you are joining in from, whether you are on LinkedIn or you are on YouTube or you are on StreamYard. Just put the comments and I would take it up with the guests for today. Now, one of the things that I started this session was around the whole idea of using AI apps and a lot of tools that we use. So I gave an example of how I use ChatGPT, and I'm sure as developers we rely on a lot of tools like ChatGPT to generate ideas, maybe Claude to process large chunks of text, and more recently Cursor to help you with the code. But behind each of these AI driven experiences, there is a highly complex and sophisticated infrastructure. And to understand how these tools operate at scale, we need to look at the backbone of AI, which is what we call the GPU cloud. And this is where all the AI magic happens. So I will hand over the mic to Vishal to tell us more about what is GPU cloud, what does it mean, and how does it help?
Cool. Thanks, Atul. We can move to the next slide. So if you fundamentally look at any cloud, basically, right, it is composed of multiple layers of hardware and software, right? And even below hardware, if we talk about the bottommost layer, we got the cooling, the power, the racks, arranged in a certain manner to optimize certain things like network or access to storage or whatever, right? On top of that, you got compute, and you've obviously got storage, basically. Compute, obviously, in the traditional data centers has been CPU. Now we have GPUs, and we have obviously very purpose-built chips also getting built by many companies, right? Storage, again, some of the most critical part of making things happen, and we'll look at very shortly how storage is so crucial when it comes to AI workloads. Now, of course, all of these things are connected by a network fundamentally, and network does play a very crucial role in moving things from one place to other place, but also enabling the communication. And again, this is very different in the GPU world compared to CPU world. We'll look at it shortly, basically. On top of that, you will typically have some sort of operating system and orchestration. And I'm not necessarily saying just orchestration means Kubernetes, but even pre-Kubernetes days, you basically had to orchestrate communication across multiple machines and instances to deliver things together to the customer, basically, right? And on top of this, you typically have your MLOps frameworks, some sort of tooling, some sort of servers running together, basically. When I'm saying servers, like software servers, basically. And at the end, you deliver use cases, right? So in case of GPU cloud, for example, you might be delivering a text to speech kind of service, or some sort of audio transcription, or video creation, maybe. Maybe you might have a developer's assisted coding assistant or stuff like that, right? Basically co-pilots in a way. Now, if we talk about differences between a CPU and a GPU world, right? So if you start fundamentally at, let's say, power, for example, right? Typical CPU racks consume, between 8 to 10 kilowatt power, and could house anywhere between 3 to 4 kind of units of the CPU compute, right? But fundamentally, if you look at the GPU world, you usually have two units. For example, NVIDIA HGX, two boxes, each box containing 8 GPUs, so about 16 GPUs. But they need a lot more power. For example, typical requirement is usually 20, 22 kilowatt. And I'm sure as new generations of GPUs get launched, they might have specific power requirements, right? So this is something fundamentally different when it comes to GPU cloud that we need to keep in mind. Similar example with cooling, right? Cooling has always been a challenge, and people have been trying to optimize. For example, you might have heard about Facebook running some of the data centers in Norway, for example, so that you could use snow and all the cool air from there, and not actually consume energy, which is produced and used by many people, right? So there are a lot of technologies again in cooling, for example, from liquid cooling to there have been some very advanced and fancy things like oil cooling, for example. Now, I'm no expert at power or cooling or racks, any of these, obviously. So we'll not go too much in that direction. But in the next few slides, we'll double click a little bit on the compute, the networking, and the storage parts, at least scratch the surface of some of the providers, technologies, and what's different in the GPU cloud world over here.
Sure,
Now, one
Vishal. So
favorite quote
before
I have. Go ahead, Atul.
Go ahead. So Before we move on, right? And when you were talking about cooling power and racks, it felt like I was literally in one empty room figuring out how to set up racks because as engineers, this is something that we barely know about because we have our systems, you know, uh, in place and we start using it. One question that I had on this was, for me, orchestration mostly deals or talks about Kubernetes. That's the layer that I frequently work with. What are some other orchestration tools probably that fit in this layer?
Sure, that's a great question, right? And in the HPC workload, there is a orchestrator called Slurm, for example, which is very popular. It's not a new one; it's probably been around for at least a few decades, if I'm not wrong. Before Kubernetes, we obviously had Mesos, we had Chef, Puppet, and all these things. And I'm sure there are other, for example, if you look at HDFS file system, inherently it's a distributed file system across multiple nodes, right? So in many shapes and forms, it's all about basically distributed computing in a way, right? And you're right about
Absolutely.
the racks and cooling and power part. Like I have seen in many companies racks, and I had seen from a usually they're in locked room, right? You can't access these things, so you usually
Yeah.
see it from outside. But when I worked with a few customers in last year or so, we got into the technical details of how to design these things, how to choose certain things, kind of thing, and that was very fascinating for me as an engineer, basically.
Interesting. And I'm sure those insights will fall over to the next slides that we are going to look at. So, like Vishal said, there are three major areas when you talk about from this image, there's compute, there's storage, and there's networking. And over the next few slides, we will be diving a little bit deep on each of these. Yeah, Vishal, you had a favorite quote.
Absolutely. So this code I picked up obviously from one of the publications by AMD, but I loved this code because when I looked at the design of data centers and when I was in workshops with customers, one thing I realized is there is absolutely no artificial intelligence without an intelligent network. So much of what we are doing and what you're able to do, not just from the servers to our machines and all that internet, right? But even within the racks and even within the multiple GPU nodes, there is so much going on based on very modern, advanced, and very interesting networking technologies. So this code is so true. There isn't really AI without the intelligent network, basically.
Absolutely.
Cool. So let's double click, on the GPU cloud networking part over here. Now, when you're building something on a single machine or a single GPU instance, I think it's fairly straightforward, right? You basically open up something like a Jupyter notebook, you will write code, you will train things, you will run something small, basically, right? But from that point, you move to probably multi GPU or multi nodes, usually, basically, right? And when you move from one to a few, that's still okay. It's still manageable, probably 1 to 4 or 4 to 8, for example. But the moment you move from, let's say, talking about, I don't know, 100 nodes or 200 nodes kind of thing, right? It gets pretty complex. And we are now talking about communication across multiple layers and levels, for example, right? So one communication is between the GPUs on the same server. So for example, if you look at this diagram, on the left-hand side, we got 8 GPUs on the same server. And then there is another box on the right-hand side, 8 GPUs on the same server. Even within this box, there is so much networking bandwidth being consumed to carry either data or do compute across multiple GPUs. And then we are talking about like these, if you have, let's say, I don't know, 32 or 64 nodes, for example, networking across these is fairly complex and it's like an n-dimensional network in a way, basically, right? And how well the network performs is going to be one of the most critical factors on the workloads that you're running. And there are very interesting technologies. For example, if you look at NVIDIA, NVIDIA has a bunch of technologies like InfiniBand is one of the technologies which enables communication across nodes, for example. NVLink and NVSwitch are two generations of technologies. It enables communication between GPUs and in some cases across nodes as well. It has a very interesting way of doing certain things and bypassing sometimes kernel or operating system, so to speak. Another interesting one is from Juniper. They have QFX switches, which are based on Ethernet ROC V2. Now, InfiniBand, is a proprietary technology by NVIDIA, whereas QFX switches are by and large based on the Ethernet protocol. It's a version 2, of the Ethernet protocol, basically, right? And that presents, again, some of the choices, some of the operational impacts, and what does it mean for you as a data center builder and operator varies quite a bit. There is also, obviously, from AMD Infinity Fabric, which I believe primarily works with the AMD, kind of accelerators or processors, so to speak. So these are some of the technologies, obviously. Yeah.
So Vishal, I do see that this image is, quite complex when you talk about, 8 GPUs. I'm sure in a data center or when you're actually building a GPU cloud, there would be hundreds of GPUs in the entire, data center. So while we understand that networking is quite crucial, what do you think? I mean, what's the whole network bandwidth, that is required when you play around with different, basically when you connect different GPUs?
Yeah, I'm so glad you brought up the point about the speed, and this is something which I really got very excited about when I heard for the first time. So, for example, the InfiniBand and the QFX switches from Juniper, uh, data science, right? Jupyter, Juniper kind of gets mixed, but they offer speed up to 800 gigabyte per second. And you can imagine, we are talking about data. For example, somebody like OpenAI is taking the data of entire internet and trying to do certain things, right? You would need to transport huge amounts of data as fast as you can. So, for example, QFX switches do like 800 gigabyte per second, at a spine level. But if you kind of spread across leaves, it might be doing, for example, 400 gigabyte per second. Very similar LV, Link, and NV switch. If you go and look at the specs on the website, they will talk about between 100 gigabyte to 400 gigabyte per second, based on which generation of technology you are using, and it is compatible with which version of the GPU family, basically. So it's very interesting to look at those kind of speeds.
Interesting. So now we know one of the reasons when we give a prompt to an LLM, the speed at which it gives, this is one of the reasons behind that speed.
Absolutely, absolutely. So one of the key factors, when you are building a GPU cloud or operating a GPU cloud, is some considerations that you will need to think from a very networking standpoint. Very crucial in terms of longer term ROI and also the operational aspects of the data center. The first one I would say is the size and form of the data center, right? So uh, typically it depends based on whether you're building like a small 8 node, 16 node, 32 node, or are we talking about like 1,000 node kind of a data center basically, right? Atul, can you move to the next point here? Yeah. So for example, if you look at HPC could be like thousands of nodes, whereas edge installation could be maybe less than like 10 nodes, for example, right? And depending on what kind of form factor we are dealing with, your network requirements could be completely different. Second very important factor is the kind of workload you're running. Are you running only inference? Are you running only training? Are you running like a hybrid workload where maybe 70% of your users are doing training and 30% are only serving the end user requests from the inference server, right? That becomes a very critical factor in the kind of speed and the bandwidth that you will need between GPUs, across GPU nodes, and across the data center entirely, basically. The third factor I believe is very crucial is the vendor lock-in and the future flexibility. So remember, I was talking earlier about the Juniper, switches. They are based on Ethernet. Now, Ethernet is a very widely understood and very well documented protocol, so to speak, right? You might find experts who have skills with Ethernet technologies plentiful in the market. Whereas potentially maybe like with some proprietary technologies, you may or may not have enough people with those skills in the market, for example, right? And also, are you running workloads beyond AI, which could be based on Ethernet? And those kind of choices are very critical for anybody who is building or trying to operate network across these data centers. So that's another factor. And the last factor, I think, which obviously applies to almost everything that you're doing, is the cost. And cost kind of comes in two forms, right? One is the cost of acquisition of hardware and the technology, if it is proprietary, for example, and the cost of maintenance, cost of operations, over a long enough duration, basically. And I think these four are probably the most critical factors when it comes to choosing network technology and topology, for your workloads, I would say. Yeah, and one place which I think is extremely useful for anybody making these kind of decisions, because you can't wait for something to happen in production or with your users and then take a call and change something, right? You might already have acquired hardware. So ML Commons is a group organization basically, and they do publish benchmarks. They also take benchmarks from proprietary vendors and publish them on their website after validation and stuff like that. So you can go on that website, choose the model Now, when I say model, basically it could differ based on are you doing like an audio use case versus a text use case, and for that model and for a specific set of accelerators or networking, technologies, it will give you some sort of benchmarking, and that benchmarking is very useful for somebody who is deciding what kind of technology to choose.
Interesting. I'm sure this table, like you said, is going to help anyone. This basically reminds me of me in childhood going through a benchmark setup, looking for whether my CPU and GPU can run a particular game. So I think this is fairly similar to that, but then obviously at a very larger level where you decide what model your system can run on. So yeah, let us move on to the next one, which is storage.
Yeah, absolutely. So now storage, there are a couple of kind of official vendors listed on the, NVIDIA site, for example. So you can look at, for example, we got DDN, Pure Storage, Veka. We also got technology companies like VAST, NetApp, and Dell Technologies, right? And all of these technologies have their own offering and solutions that are out there. But there are some factors that we need to keep in mind, when we choose a storage provider, right? So the first and foremost, I would say, which is the most critical, is the compatibility with specific vendor technologies. So, for example, some of these, and I believe most of these do integrate with the underlying accelerators technology like RDMA. But one of the most critical factor, I think, is that it keeps up with the advances in the underlying GPU tech when it comes to storage, and integrates with the underlying GPUs very well. The second is, if you only look at AI as isolation, that might be one use case, right? But large enterprises, for example, if you're running, I don't know, like a Fortune 500 kind of org, you might be having other use cases, other workloads, and other needs. You might need object storage on premise. You might need SGFS file system because you have been running, Hadoop workloads for last like 2 decades and stuff like that, right? So any technology which can actually cover a breadth of these technologies, and in case one technology cannot cover, you might not actually switch and have maintain two technologies parallelly, right? That's probably another very important factor. The third one is the software only versus appliance. And obviously if you're only using software based, the hardware dependencies are equally critical, and that could decide the kind of technology you end up choosing. And lastly, like we spoke about storage, for example, so networking benchmarks are published by ML Commons, but for storage performance benchmark, there is a company or an organization which publishes the storage benchmarks for various technologies, basically. So I think for both of these, it is very critical to look at the benchmarks, look at the use cases, and look at other factors like economics, cost, extensibility, and the vendor lock-in before you go ahead and choose these technologies.
Great. So we are done with networking. We have looked into storage, and now let us move into what is called accelerators.
Right, absolutely. So obviously, so accelerators, we got obviously NVIDIA, the big elephant in the room in terms of A100s, H100s, and P100s. But even beyond those, there is, for example, L40. Now, L40 is one of the most popular ones when it comes to running inference workloads. And one of the reasons it does so is because of its superior T-flops performance, basically. And we have a post coming up probably in a few weeks from now as to comparison of T-flops, across various accelerators, because that is one of the most critical factors when it comes to deciding which accelerator to use. And then obviously future needs and costs, right? For example, could you be running workloads which are non-AI on the same accelerator? Are you going to be running inference workload or training workload? Or there are going to be more kind of workloads tomorrow which you can reuse with the same accelerators, because efficiency of running workloads on those is probably one of the most critical factors here.
Interesting. So, Vishal, before we move ahead, I think there is a question related to storage, and I think it's good that we address it now rather than waiting till the end.
Sure.
So I'll
Sure.
bring up the question on the screen. So we have Anil from LinkedIn, Anil Kumar Varakukala. Sorry if I'm spelling your name wrong. He's asking, have you noticed storage performance limitations of the existing solutions that result in GPU stalling?
To be honest, I don't think we have reached or worked at that scale so far. But I have definitely heard, based on other companies that we have spoken to in past, about some specific solutions hitting some limits. And I don't know specific names, but there are definitely some challenges, that certain combinations or workloads might be running into, I would say.
Sure. So Anil, probably, maybe 3 webinars from now, we might probably have this answer. Thanks for that question. Let us
So
move
just
on to,
Atul, just want to add
yeah,
a point there.
sure.
So most of the traditional storage vendors may not adapt to the latest hardware, you know, uh, enhancements, for example, GPU usage or RDMA technology usage. So most of the whichever storage vendors are leveraging these, hardware innovations, latest hardware innovations, they would be doing better in benchmark. So that's where the NVIDIA certifies a couple of storage vendors on their website.
Interesting. That's a good way to look at it, and that's very practical as well, because if the vendors themselves are not upgrading on certain points, they will eventually create a bottleneck at some point or the other. So that's a very valid input. Thanks, Sanket. So we can move on and finally get to our AI lab.
Sure. So based on all this work that we've been doing, with customers and prospects and stuff, at some point we realized, we kind of need our AI lab. So this is, we'll talk about obviously the technical specs of it. But before I talk about the technical specs, I would love to talk about why we built an AI lab first place, right? So our motivations behind building the AI lab. So one thing is, once you have hardware, you have complete control over everything from ground up. You could decide what operating system to put on it, what way to boot operating system, not just choosing the operating system, but also how to boot it up from scratch, right? And this lab basically is a great, kind of imitation or a smaller version, I would say, a miniature version of the GPU cloud, because fundamentally the CUDA, the layer that sits on top of, GPU, is fundamentally the same. So you could, build, run all these things locally. It has great accessibility. We can run it 24/7 if you want to. And obviously there is certain cost implications of, having or being able to run things 24/7, for example. And once you have built things, tested them to a certain extent, you could deploy the same stack exactly on cloud, for example, or on a provider of GPUs of production grade or customer, for example, and then scale, over there basically. So that is the motivation, I would say, by and large, to build an AI lab. So now let's go and look at the actual stack. So we basically got, three Intel NUCs. These are used more as a control plane, so to speak. One of them acts as a bastion host. One of them is a Kubernetes master, and the other is a worker node. A worker node is typically used to run things like, Prometheus master and stuff like that. Then we got three GPU boxes. These are GPU worker boxes, basically. They're running an RTX 4090 with about 128 gigabyte RAM, network card attached, for 10 gigabyte, and an i9, 32 core CPU, basically. And then they have attached, 1 terabyte of SSD and 2 terabyte of SD, right? Now, remember, if you talked about, networking technologies and the network bandwidth between, multiple GPU instances, we also talked about the storage technologies and stuff like that, right? But here we made slightly different choices. For example, instead of having a storage technology and running them separately, right, we basically attached as much possible SSD to the same boxes, and then we ran kind of NFS on top of that. Or our networking cards, for example, they're only 10 gigabyte, which is not, as I was saying, 800 or 400 gigabyte per second, basically, right? But you don't need that kind of stuff for a local lab. You'll obviously need something like that for production. But this is good enough, for this kind of, miniature version of the lab, I would say. I'll let Sanket talk about the stack which is running on this a little more in detail, like NFS and stuff like that, and also go talk about what we are running and give some demo, of the live lab. I think he's right, next to lab, if I know it.
Yes. So this is now over to Sanket, who is actually sitting in our AI lab room.
So we get the hardware that we have, right? We essentially move on to the software stack, what things we deploy, and ensure this hardware is ready for, let's say, our AI usage. Can we move to next slide, please? So first task is to install some operating system on these hardware boxes that we have got. So mostly we use PXE booting. So PXE booting is where you remotely boot instance and then install operating system on that stack. So we have been familiar with PXE boot, TFTP, DNS mask, all these technologies. We have implemented stacks. So here we use raw DNS mask server and just install Ubuntu OS on all the nodes that we have. Once that is done, we install Kubernetes on these nodes as a base layer so that we can run all the workloads as containers. So it simplifies a lot of things for us. And then essentially to make GPU accessible for our use case, we use GPU operator, which is solution from NVIDIA. So GPU operator helps you installing NVIDIA drivers and a couple of additional components that NVIDIA provides. Also, to leverage the networking cards that we have, we use networking operator. So this stack pretty much stays same. So depending on even in data center, probably would need GPU operator, networking operator, these solutions. And Metal LB is a load balancer. Since we have a raw lab, we use Metal LB just to grant IPs to our Kubernetes services that we create. And on top of that, like we have monitoring. So essentially, we just use Prometheus to monitor all the workloads that we run on our Kubernetes stack, as well as to monitor all the GPU devices that we have. We use NVIDIA Data Center GPU Manager Exporter, that is DCGM. So one of the critical things that we have to do is we download all the models, open weight models from Hugging Face or different locations, and we make those models available in our NFS, as well as typically if you look at container images, which comes from different vendors to run all these workloads. They are huge in size, so we also download those in NFS so that we optimize on like provisioning time in general. So this is pretty much software stack that we have, and then we build different AI apps and AI workloads on top of this.
Right. So I think Rajendra, you had a question where you asked where is Kubernetes in terms of GPU scheduling. I think this tags gives you the answer where it is and what we are doing with that. So let us move
I
on
think
to the
Rajendra's question also kind of points to the fact that is it mature enough? Do you want to answer that, Sanket?
Yeah, so typically, you depending on on which nodes you have GPU devices attached, you need to ensure your workloads go on those specific nodes, right? And now the default scheduling that Kubernetes you get with GPU operator and Kubernetes, that may not be optimal. So definitely there are enhancements, etc., that you need to consider, and there are different techniques also. How do you, let's say, for example, if you have one big GPU and if you want to run multiple workloads on that GPU, then probably you will do like slicing, or there is a technology or solution called MIG, which is additional to sort of a GPU scheduling. So there are different techniques for GPU scheduling. We have also written a blog around these things where we have talked about vGPU, MIG, and time slicing. So definitely check out that blog as well.
Yeah. I think
So
Atul might as well add, but I think there is efforts going on within the CNCF also. For example, there is dynamic resource allocator, which is now probably part of like latest 1.3 at an alpha level, I believe. But there is maturity that's going to increase in next few releases, I believe.
Yeah,
yes.
as Vishal mentioned, there are definitely a couple of adjacent solutions which are being built to efficiently use GPU resources in orchestrator like Kubernetes. Moving on, so once we have Kubernetes and the base stack where NFS, Prometheus, Grafana, and GPU operator, load balancer, etc., we do deploy all the services, LLM microservices or AI microservices that we require. For example, re-ranker, LLM embeddings API, etc. So we deploy these services through Helm chart that we have deployed. We have also open sourced this Helm chart. And so we deploy all these services on our Kubernetes cluster. So we use models like Llama 3.18 billion, etc. So we deploy all these microservices. And once we deploy these microservices, our AI apps use these microservices, which are natively deployed on our lab, and then we try to build different AI use cases, for example, chat, RAG, or maybe building AI agents, etc.
Interesting. So I think before I move ahead, there is a question from Tushar who is asking, did we tested NPS as well? So apparently it's a NVIDIA offering for deployments. So did we try that, or uh, what is your experience on working with NPS? Anyone can
So
take that.
we haven't tried MPS per se. We didn't feel like need of it for our use cases. Mostly we have used time slicing or vGPU, which is alternate solution, or otherwise MIG is more like a hardware level isolation for GPU resources. So our inclination is more towards MIG or similar kind of solution rather than MPS, etc. But yeah, definitely we'll check out on it more and probably will share details.
Great. Thank you, Sanket. So I think we can move on to the next slide, which is the most exciting part of the webinar that everyone looks forward to, the actual hands-on to see everything in action. So before Sanket actually dives into the demo, uh, all the things that you're going to see in the demo, the Helm charts that we have used are all open source and they are available in our repository. So all you have to do is scan this QR code. It will take you to our GitHub repo where you will find all the charts that are in place, which you can use using Helm and set up your own AI lab. So all the applications, all the configurations that we have here are present in those charts. So if you wish to build your own lab and have a similar setup, all you have to do is just scan this QR code, go to the repo, fork it, and then just start building your own lab. I think this duration is enough for all of you to scan the QR code. I'll hand over to Sanket for the actual live action. So I guess, yes, Sanket,
Yeah,
it's all yours.
you can share my screen.
Sure. So, yeah.
Cool. Yeah, so I'll quickly walk you through our AI lab. So I have a couple of nodes in my cluster as of now, and you can see like there are 4 worker nodes and 1 master, and one of the node currently is in maintenance. So then, like we can see, let's say the nodes which have GPU present. So these are the nodes where we have GPUs as of now. And so just to showcase how we enable GPUs, through GPU operator. So we install GPU operator Helm chart. So these are the values, for example, we have passed to or we have used to install GPU operator. So we use device plugin. Then I've also enabled time slicing. So that means I can use same device to deploy multiple workloads. Then we use pre-compiled drivers from NVIDIA. So this helps us, do a bit of optimization so we can quickly install the drivers for all the NVIDIA drivers, NVIDIA devices. And then we have DGCM exporter, which we help in collecting different metrics for Prometheus, etc. So, and if we look at the workloads that this Helm chart deploys in general, just to showcase like, so for example, this Helm chart, which we have deployed, creates couple of daemon sets on our Kubernetes cluster. So this will be enabled on all the nodes that have GPU device or GPU card installed. So typically, you see the daemon set is enabled, NVIDIA driver daemon set. So this daemon set will install NVIDIA driver, and once that is done, you need to expose this particular driver and NVIDIA device to your Kubernetes workloads or which are running in container. to your AI workloads. So in this case, we have container toolkit and device plugin, etc. So these are things which enable your Kubernetes to access GPU device and run the workloads using the GPU, right? So yeah, so this is how we get the GPU devices enabled. Now I'll just quickly walk you through the AI services that I've deployed. Uh, So in the infographic I showed, there are different AI microservices that we deploy, right? So we can see here we have TGI, TEI, re-ranker, and vector DB, a couple of services which we have deployed through our Helm charts. So and we can quickly go through, let's say, so this is the TGI service, which is LLM we have deployed through our microservice. Now let's check out quickly which LLM is this.
Sanket, maybe you want to zoom in a little bit on the UI? Yeah.
Sure.
Yes.
Yeah. So we can probably see the info, or there are different APIs, or this is the API spec that we get. And from the API spec, probably you can figure out which LLM is deployed, etc. So these are so for example, we are using Llama 3.18b instruct model. And these are a couple of configuration options that we have mentioned in our LLM deployment. Now we can quickly make an API call to this LLM. I hope the font is visible.
Yes,
For
it is
example,
visible.
I'm just making like a simple call, the skies, and then probably I'll set like a number of tokens to 200. I'll execute this API. So we get the response, and probably you see some sort of text is generated for the request that we made. So this is how we invoke different AI microservices through APIs, etc. Now we also monitor all the GPU devices that we have. So these are the high-level metrics that I'm currently showing. Like for example, we monitor temperature, power consumption, GPU utilization, and memory consumption, etc. So this helps us in just identifying any faults or how we are utilizing all these GPU resources, etc. So yeah, this is pretty much high level what I wanted to cover. And we also access all the metrics from all the microservices that we have deployed. So yeah, this is pretty much high level overview I wanted to cover. Okay, over to you.
Interesting. So I think the response that our TGI gave us when you wrote the sky is, I think it actually knows what the weather is like in India. It actually replied saying that the weather, the sky is gray and the wind is blowing. So I think it has its own intelligence that is, playing a part over here. But thank you so much, Ankit. I think, it gave a lot of insights into how the entire lab is set up. And also, how we brought the entire gamut of a GPU cloud to something which is manageable, something that suffice our needs, and something that we can build grounds up and have full control over it, right? So like I said, everyone, whatever you saw here, you can deploy it on your own systems, if you want to. So once again, I'm putting this QR code here, so you can scan it to get the charts and have a similar setup for you. So while you scan this code, I will go through the bunch of questions that we have received, and we'll be putting them up on screen in a while. So the first question here comes in from Shiva, and Shiva asked us, did you had any requirement of running complex processing database in GPU nodes on Kubernetes?
Not so far. I think there have been conversations or trials of people running Sparks, for example, on GPUs. But I don't think we have done anything so far.
Sure. Then I think we have next question from Sujay. He is asking, please shed some light on the cost. Some light.
Yeah, Sanket, you want to give it a shot? Like approximate range is good. You don't have to be precise with numbers, but
Yeah, so I think we built out these servers, which is, I mean, we have procured 3 to 4 machines right now, and then overall, we have a couple of NUCs, etc. So, yeah, in broad level, we have around like 15 to 20 Ls of spend, and then effectively, like, of course, the broad setup is a bit different.
yeah. So basically, like 20-25K USD about is the cost. Yeah. Okay.
Yeah. Hope, Sujay, that answers your question. We are moving on to Siddheshwar More, who asked us about what were the challenges faced on two fronts. One is OS hardening, and second one on selection of tools and hardware. And I think the cost part we already discussed and spoke about.
Yeah. So at least one of the critical factors when you think of like installing GPU drivers, you have to check first whether your OS is supported or not. Because, for example, latest Ubuntu 24 OS 24.0.4, right, is not supported yet by NVIDIA to install these GPU drivers. They're only certified until 22.04. So these kind of things you will face. So we did a lot of iterations on these kind of things, of course, and then you have to ensure, even if there is a kernel version upgrade on OS, you need to ensure your uh, NVIDIA drivers are compatible with that particular kernel version. So you have to do all the metrics. You have to consider OS version, kernel version, and your GPU device or GPU card. So all these three combinations you have to consider when you're installing GPU drivers. Then selection of tools and hardware. So right now we are using GPU operator, as I mentioned. So there are different ways to install these GPU drivers. You can directly install with, let's say, something like apt-get, or you can use pre-compiled drivers the way we are using it. And of course, depending on what kind of GPU device you have, for example, if you have A100 device, etc., or let's say if you're using state-of-art technology like NCCL and NVSwitch, which Vishal explained earlier. So then you have to build additional, you have to bring in additional components to enable all those hardware devices. So definitely all these things you have to consider when you're building on top of specialized hardware.
Thanks, Sanket. I think Siddheshwar, I hope he answered your question. The last question we have again from Shiva, who is asking, what is the minimum hardware requirement to run the lab on your own stack? For learning. So I would probably take a stab. Probably then I would give it to Sanket and Vishal. So I think the QR code which I shared for the charts that we have, if you have a setup which has an NVIDIA card, which is compatible, let's say, with the GPU operator, and you have Kubernetes on top of it, I think then it's fairly correct to say that you would be able to just use the start directly as is and have the entire setup in place. At least that's what my understanding is, at the moment after seeing the setup and after going through the charts. But I would want Sanket to validate my understanding of this.
Yeah, so definitely, when you say minimum hardware, you need uh, some kind of GPU device from NVIDIA, at least in the current picture. And like depending on what kind of models you want to run on this stack, let's say if you're just talking about LLM workloads, right? For example, if I want to run Llama 8B model, definitely I need a GPU which has approximately at least 24 GB of memory, etc. If I run like a full FP16 model. Now, if I'm running quantized model, maybe I can use like a lower level GPU, etc. So, and if you are running like a very large models, then you need multiple of GPU devices. So, uh, with minimum hardware, let's say like card that we have RTX 4080, maybe you can just run like Llama 3.1 B models, etc. So that is sort of, we can say, minimum hardware as of now.
Yeah, I would also add to that, like most of the Apple M1 M2 series laptops with decent enough RAM can also run local models with tools like Olama or Llama. There's a bunch of tools. I think we'll have a webinar plan at somewhere in time on those tools, specifically about running LLMs locally. But you should definitely explore like a M1 M2 laptop if it is just purely for personal purposes, basically.
Yes, I agree to Vishal. I did run Olama on my laptop using, again, like Sanket said, it depends on the LLM that you're using. So you can very well use a smaller footprint LLM on your own laptop with Olama, and it'll just work. But I think what I just shared a link in the chat. You can see it on the screen as well. This tool on Hugging Face will actually tell you whether you can run a LLM on your system or not. So all you have to do is, just open this, choose an LLM that you want to run, and provide your machine specifications in terms of the compute, in terms of GPU, and then it will tell you whether your system would be able to run that LLM or not. So, if you want to build a lab of this sort, I think this would be a good place to get a ballpark estimate of what your system can actually run and what you need in addition to get your work done. Uh, yeah, so I think we are at the
Because there
hour,
are two more
and
questions I
yes,
found on the LinkedIn, but they're not somehow streaming into StreamYard. So can you pick up them from the private chat and just repeat them, please?
sure, I will pull them. And I wish AI could help us solve these problems of comments not coming in from LinkedIn to here. So I'm just showing up that question. I'm sorry who has asked this question, but the question here is: have you benchmarked the pod initialization time when loading large models?
Yeah, this is from Nitin Ravi. But comment, do you want to, sorry, Sanket, do you want to comment on this?
Yeah. So yeah, the pod initialization time, so it consists of a couple of factors, I would say. First, like let's say if you're storing these models at certain NFS, etc., then pulling all those model weights, then loading these model weights in GPU, and then actually all the like if your model is divided into different shards, so it takes a bit of time, I would say. And then if you have like multiple GPUs which are running this model, then definitely all the coordination, etc., that takes a bit of time. So uh, for our case, let's say it takes, since we have models already available, typically model will just start in a couple of seconds, like 5 to 10 seconds, etc. It doesn't take that much time. But yeah, like if you are actually pulling the model in runtime and then running it, etc., it may take a bit more time based on your network bandwidth and depending on the how you are running your setup.
Yeah, and I think that's where the initial part of our webinar would help in terms of the importance of network, the importance of storage. How that decide your entire latency and timing that comes into the picture. Last question coming in from Gautam, who asked, "Are we using any AWS, Azure, or Google service in our stack at the moment?"
Nothing, I
Since
guess,
this is
as of now.
on-prem, no, since this is on-prem setup, everything is local, and we
Yeah,
don't,
yeah.
apart from like fetching models, we don't really connect to internet. That's it.
Yeah, one service we could probably use at somewhere in time, Gautam, to answer your question is there's a distribution of Kubernetes called EKS Anywhere from AWS, and that seems like good distribution, and we could probably deploy it in one of the iterations. But right now we're not using anything. Obviously, as we progress more, we might end up picking any open source stuff from these companies and try them on the prem.
I hope, Gautam, your question is answered. And I did feel that today's webinar, in terms of Q&A, was like an in-person meetup. Mic going around the hall and people asking questions to the panelists and presenters. So I think it was a great webinar today, especially being the first one in our AI Explore series. And we would be doing more such webinars in the future as well on AI. Like I said, we would be exploring length and breadth of AI, from AI platforms to infrastructure and frameworks and applications. So if you want to be updated of all our upcoming webinars, do scan this QR code. It will take you to a form where you have to just fill in some of your details. And every time we go live or whenever we publish a webinar, you will be notified of it. So you will not be missing anything. So thank you so much to everyone joining in. Thank you, Vishal and Sanket, for sparing time and teaching me and all of us about the AI lab and how the entire GPU cloud and AI lab is not just limited to GPUs, but there is far more contribution of storage and networking to it as well.
Yep. Thanks for driving it, Atul, and thank you.
Great. So thanks everyone. Do follow us on our LinkedIn and Twitter pages and be ready for the next webinar that's coming in your way. Thank you so much and have a wonderful day and wonderful evening. Bye bye.